Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting presentation for DTC P0103, which indicates a high voltage in the mass airflow MAF sensor circuit. This diagnostic trouble code is pertinent to the Honda Civic models from 2006 to 2011. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, allowing for optimal fuel delivery and engine performance. By detecting air intake, this sensor communicates pertinent data to the Engine Control Module, ECM, which adjusts fuel injection accordingly. High voltage readings from the MAF sensor can lead to performance issues, as the engine will not receive the proper air-fuel mixture necessary for efficient operation. We'll explore symptoms, possible causes, and step-by-step troubleshooting to help you resolve any issues with this fault code. DTC P0103 signifies a high voltage condition in the mass airflow MAF sensor circuit. The MAF sensor is a pivotal component situated between the air filter and the throttle body in the intake system. Its primary role is to determine the volume of air flowing into the engine. This data is vital for the Engine Control Module, ECM, to calculate the optimal fuel mixture necessary for combustion. If the MAF sensor sends readings indicating excessive airflow or a high voltage, it could result in improper fuel adjustment, leading to diminished engine performance and increased emissions. The MAF sensor's location ensures that it gauges the airstream directly after it passes through the air filter, ensuring accurate measurements. Understanding this component's function is essential in diagnosing the issue effectively. Identifying the root cause of DTC P0103 involves understanding several potential issues. A faulty MAF sensor may be the primary reason. These sensors can degrade over time due to contaminants or internal failures. An open circuit in the wiring can also cause significant impairments, preventing the ECM from receiving accurate data. Additionally, loose or corroded terminal connections at the MAF sensor or the ECM can lead to intermittent failures. It's crucial to inspect both the MAF sensor and its associated wiring thoroughly. Lastly, while less common, failure within the ECM itself can also contribute to inaccurate voltage readings, necessitating comprehensive diagnostics and testing for this possibility. The symptoms associated with DTC P0103 can significantly impact vehicle performance. One of the first noticeable signs is the illumination of the check engine light (CEL) on the dashboard. This warning indicates that the ECM has detected a fault within the engine management system. Additionally, drivers may experience poor engine performance, such as hesitation during acceleration or rough idling, due to erroneous air-fuel calculations. Increased fuel consumption is another common symptom. The engine may compensate for the high voltage signal by altering fuel delivery, leading to inefficiencies. If these conditions persist, they can cause further complications, including damage to the catalytic converter or reduced overall vehicle efficiency. Addressing these symptoms promptly is vital for both safety and performance. To begin the troubleshooting process for DTC P0103, first, turn the ignition switch to the on second position. This action powers the vehicle's electrical systems without starting the engine, allowing for diagnostics to be run safely. After switching on the ignition, wait for a minimum of 2 seconds to let all systems stabilize. During this time, it's important to take note of any freeze data and onboard snapshots that the vehicle's diagnostic system has recorded. Freeze data provides a snapshot of critical engine parameters at the time of the fault, which can be incredibly beneficial for identifying underlying issues. Additionally, Reviewing any onboard snapshots might help outline what happened before the check engine light was activated. After recording the freeze data, the next step is to check the MAF sensor data using the Honda Diagnostic System, HDS. This tool will display the MAF sensor readings in grams per second, GM per second, or voltage, V. Ideally, you should look for a reading of about 202 GM per second, or a voltage of 4.89 V. If these values are indicated, it points toward a potential issue within the circuit. This data is crucial as it displays whether the sensor is functioning at expected levels or if high voltage readings are genuinely present. If the readings are within specifications, this suggests that the system might be fine, and the next action should be to investigate potential intermittent failures or connection issues. For troubleshooting step 3, turn the ignition switch to the lock 0 position. This action ensures safety by cutting off all electrical power before performing any disconnections or tests. Next, jump the SCS service check signal line with the HDS, which allows for more comprehensive diagnostics to be performed. Proceed by disconnecting the MAF sensor and IAT intake air temperature sensor using their respective 5P connector. The IAT sensor works in conjunction with the MAF sensor to provide accurate air temperature readings to the ECM, enhancing the overall air density calculations for fuel injection adjustments. Detaching these components will prepare you to conduct continuity tests and check the wiring for potential faults. In step 4, you will check for continuity between the MAF IAT sensor connector terminal number 4 and the corresponding terminal B32 in the ECM PCM connector B44P. Using a multimeter, verify that there is a proper path for electrical current between these 2 points. This step is essential, as open circuits can cause failures similar to the high voltage condition indicated by DTC P0103. Referencing appropriate wiring diagrams can assist in identifying the correct terminals and ensure accurate testing. If continuity exists, this signifies good connectivity. However, if there is no continuity, it will be necessary to repair the open circuit in the wiring to restore proper function, effectively targeting the root cause of the DTC. In troubleshooting step 5, reconnect the ECM-PCM connector B44P to ensure that all components are hooked back up correctly before proceeding to the next phase of testing. The continuity test will supply valuable feedback, but creating a controlled environment for further tests is critical. After this reconnection, set up for a jumper test. Use a jumper wire to connect terminals number 3 and number 4 on the MAF IAT sensor 5P connector. This step allows you to simulate normal sensor operation, pinpointing if the issue resides in the MAF sensor itself or if it is being affected by other factors in the circuit. Make sure the selected jumper wire is suitable for the voltage levels involved to prevent any additional circuit disruptions. In the final repair verification step, turn the ignition switch back to the on second position. This reactivates all electrical systems and allows for final diagnostics. Use the Honda Diagnostic System, HDS, to clear any diagnostic trouble codes that have been previously stored. This essential step refreshes the vehicle system and helps ensure that old codes do not interfere with new testing. After clearing the codes, check to see if DTC P0103 has reappeared as either a pending or confirmed code. If the code does return, it indicates the repair may not have resolved the underlying issue, warranting further inspection. However, if no codes appear, this suggests a successful resolution of the problem. to prevent future occurrences of DTC P0103. Performing regular maintenance on the MAF sensor is advisable. Routine inspections might include checking for dirt or debris that can impede sensor function. Ensuring that the air filter is clean is critical for optimal performance. A clean air filter helps maintain accurate airflow readings and ensures that the sensor remains unaffected by contaminants that could skew data. Additionally, regularly monitoring electrical connections for looseness or corrosion can avert issues related to high voltage signals and intermittent failures. By implementing these maintenance strategies, you can help to ensure the longevity and reliability of your Honda Civics engine management system. In conclusion, diagnosing and addressing DTC P0103 involves a methodical approach focused on the MAF sensor and its associated circuits. Understanding the role of the MAF sensor and maintaining proper connections is vital for effective vehicle performance. Begin troubleshooting by assessing the sensor data, checking wiring connectivity, and performing necessary repairs as needed. Regular inspections and preventive maintenance can help mitigate future issues, thus promoting a more reliable and efficient engine operation. Always remember to utilize the HDS system for diagnostics and troubleshooting to ensure you have the most accurate vehicle data available. This comprehensive understanding will not only enhance vehicle performance, but also prolong the overall lifespan of your Honda Civic. Please like and subscribe to the channel. See you next time.